No, from basketball last night.
Oh.
Awful decision. When you get old, there's always time for you to say, was it really worth it? And you can pretty much always ask say the same response back. You'll understand. I remember being your age and saying the same thing. When I was 20, the difference between being 20 and 21 was like a significant, you just could tell, like 1 year, it was like, oh my gosh, this is what old feels like.
And not like the 50
No, but maybe it's because, playing a college sport, you eventually feel the wear and tear of the year-roundness of the sport, but. Alright, we're going to balance these. I'm sorry, guys. I will stop my doing either. $100 says it was Santa Maria. After first step of balance of chemical equations, do not change them, then poop.
You should probably check the other ones too.
Oh yeah.
It's already big teacher.
Alright, I'm feeling a little better that there's not anymore. Okay. I'll change this one.
Teacher.
There you go.
You don't left it for the other class.
No, they're so immature.
Oh yeah.
It's just a bad idea.
Oh yeah.
The
They're
good
the
poop
immature
and they're
ones.
with Chanel.
Okay. I'm actually going to do the first problem in your homework.
Really?
Write it down.
Such a nice teacher.
Wow. Not an 8. That's an S. That's an 8.
Oh, you're a G. Oh, why are you doing? Why is this so hard?
So we're going to balance this gentleman. Okay, first and foremost, what we did on Friday was we wrote out the chemical equations, correct?
Yeah.
And I don't know if you guys were noticing, if you looked at your reactants and you looked at the atoms in your products, they didn't match up. What you should have seen is either atoms were destroyed or atoms were created. Well, last time I checked, that's never happened outside of the creation of the universe. Okay? So we need to show that things aren't created or destroyed. And the way we do that is balancing, and is what you're going to learn today. Okay? We're starting simple. Today all we're going to do is we're just going to balance from the equation. I'm not making you write the equation first. That's coming later. You will write it, then you will balance it. Okay? Yes? Yep, that's what that would mean. But that's a really large number. Okay? So here it says, number 1, write formulas for all reactants and products. This is really number 1, assuming you were given the word equation and not it already written for you. Does that make sense? Okay? Because if I gave you the word equation, you would have to first write the formulas, correct? You have to write the equation. Okay? And it says, make sure all the formulas are correct. Why would it be bad if you didn't have a correct formula? Can you balance it if you don't have the right formula? No. Okay? Once they are correct, no touchy. Here's what I mean by this. You can't go, oh, I got 3 sulfurs over here, so I'm just going to go like this. Whoa. Can't do that. That's a completely different thing now, isn't it? No touchy. So, if I cannot change those subscripts, what can I do? Ouch.
Why?
How do I do that? Okay. I'm not as dumb as I used to be. My brain's going out. All right. So if I cannot change those subscripts, what can I do? Let me show you. Maybe T-chart. Oh yeah, I know it's kind of vague right now until I show you what a T-chart is and how you make it. It does have a resemblance to a T. All right.
Whoa.
Hey, who would have thought? All right. On your T-chart, you need a little left side, right side. You could do reactants, products. I don't care. Not funny. You could do a little reactants or products. That's what this is going to refer to. Okay, L just means left side of the arrow. R just means right side of the arrow. If you need to put, write what that means next to it, go ahead. Okay? And then what I'm going to do is I'm going to start counting how many of each atoms I have of each element. Okay? So what are the 2 elements that I have in this chemical equation? I have phosphorus and I have sulfur. Okay? Then I'm going to count how many on each side I have. Okay, it's not overly difficult. Jared, could you tell me how many phosphoruses I have on the left side? 4. Put it in there. Ethan, sulfurs on the left side. Moira, phosphoruses and sulfurs on the right side. Okay, so you should see, I know you probably saw it before you made the T-chart, but this makes it painfully obvious that what? Yeah, I destroyed 5 sulfurs based on leaving it this way, which is not okay. Is that better? Okay. So here's what we can do. We can put in a little number that's known as a coefficient. I wish I had defined that for you. You haven't seen that word, have you, before? There's no vocab sheet for this chapter. It is straight up, no extra credit for this bad boy. Okay? Alright. So what a coefficient is. Let me just side note talk about a coefficient. Let's say I've got the formula CaCl2. That number right there is called a coefficient. Okay, notice it's not a subscript. Okay, it's a number in front of a formula. Any idea what the number in front of the formula tells you? How many of that formula you have? So if I don't have a number in front of it, I'm assuming I have how many of them? 1. If I have a number in front of it, it's going to tell me how many of each I have. So if I had a 2 in front of this, how many total calciums would I have? 2. And how many total chlorines would I have? 4. Each calcium chloride has 2, so if I have 2 of them, I better have 4 total chlorines, right? Make sense? So this is how we're going to go about balancing the equation. No! Yeah, I don't know. What do you think? That seems right. Adjust coefficients until there are equal numbers of atoms on both sides? That makes sense. Okay. All right, get that in. Alright, so, let's look at this. So I said I could put a coefficient in any one of these three spots and try to get these atoms to balance out. Okay, if we look at it currently, my phosphoruses are already supposedly balanced, but what isn't balanced? The sulfurs, okay? Could there be a coefficient I could put in front of this that would take a 3 and turn it into an 8? No. The answer is no. Okay? There's nothing you can multiply 2 by from a whole number standpoint that will get you 8, right? 2 times 1 is 3, 2 times 2 is 6, 2 times 3 is 9. Not going to happen. Okay? All right. What do we do in this case? I said 3 times 3, didn't I?
You said 2. You kept saying 2.
That's up there.
Okay, everyone makes mistakes. Everyone has those days. All right? Okay. So, in a situation like this, have you ever heard of a fancy little phrase called least common multiple? Is there a least common multiple of 3 and 8? What is it? 24.
Oh, yeah. I was right.
Right? So, what would I have to multiply 3 by to get 24? 8. So let's come over here. Let's put an 8 here. Okay, hopefully you're paying attention and following very closely. Because if you're taking notes here, you'll have the answer to your first problem in your homework. Now, let me see what the next one. Now, when you put a coefficient in front of a particular formula, you must fix your T-chart, because isn't that going to change the things that are in your T-chart? Okay? So, we already said that putting an 8 here, having 8 of these guys is like saying 8 times 3 gives us how many? 24. And I could write 8 of them out if you wanted to add 3 and 3 and 3 and 3, but you guys get the idea, right? Okay? So come and change this to 24. Okay? Does that 8 only affect the sulfur? No. It also affects what? Phosphorus. Well, Mr. Kramer, my phosphorus is already equal. I don't touch it. It's okay. It's okay. It's okay. So, what does that change to? 32. So it's like distributive property in math. Whatever's in front here, you multiply to both. Does that help you understand what you got to do for that? So this turns into, what did I say?
32.
Okay, just making sure you can do mental math. Okay. I taught algebra 1 for a long period of time. There was many students who did not know how to do that. Okay. Well, I just made a mess of everything, didn't I? But did I really? Can I come over here and fix some things and get it to balance now? Okay? I don't care which one you start with. Which one you want to balance?
Phosphorus.
Let's balance phosphorus, okay? I can put a coefficient in front of this to get it to balance out, because 4 goes into 32, doesn't it? How many times?
80.
Change this to 32. You remember how I said the plus arrow separates reactants? So notice I did not take this coefficient and apply it to this, because it's not anywhere near it. It has nothing to do with it. Okay? So the coefficient only works for the formula that it's with. Does that make sense? Okay? So I balance my phosphorus, and I can finish by balancing my sulfurs by putting a coefficient here with what number? Are we balanced, ladies and gentlemen? Did we touch the subscripts at all? No. Can you do multiplication? And you can balance chemical equations. Because you're looking at me like this is hard. Is it hard, Emma? Well, you were counting, so that's a little.
Is that the answer?
That is your answer. Your final answer.
Thank you.
Ready for some hints, and then we'll get some more problems. Whoopsies. Now these hints aren't going to help you. You won't have to think about these hints in every balancing chemical equation that you do, but they're just some helpful hints if you come across some road bumps. Alright, number one, balance one element at a time. It's kind of common sense, isn't it? If we try to balance a whole bunch of things at one time, is it likely you could make a mistake? Just common sense. Take it one step at a time. Number two, it says start with an element if combined appears in only one compound per side. What that simply means is, and we'll get to an example like this, I'm sure. I'm looking at this. There is an element that appears in both of those compounds. What element is it? Oxygen. It becomes much more difficult to balance something that's in multiple things per side. So, the easiest way to try to deal with this is to ignore it. And the reason why I say that is a lot of times when you balance the other things, it works itself out. That make sense? Okay? Then it says, balance hydrogen and oxygen last, and the reason why that is the case is because hydrogen and oxygen are the most common culprits of breaking that rule. What do I mean by that?
That they show up multiple times.
Yeah, oxygen tends to show up a lot. Okay? Now, I'm guessing this problem here has neither hydrogen or oxygen because it's an easy one. Start easy. You can probably do this in your head, but that's okay. We're going to start with the easy ones. I actually gave you a harder one, the first one we did. Ready? Let me get a fresh little marker up here. Okay, since we're not having to write the formula, do we have to worry about anything in step one? No, the only thing we have to think about with step one is no touchy what? The formulas. No change in subscripts or anything like that. I can't go, oh, I need 2 fluorines over here and do that. Because guess what? That doesn't exist. It's not a thing. Not possible. Not stable. You won't ever see it. Okay? So no touchy. Second step is to make a Right, not too hard, left and right side. That's an awful T. Okay, identify each atom that's involved. Tina, give me an atom that's involved. Sodium. Shane, give me another atom that's involved. Everett, give me the last atom that's involved. Okay. Rose, can you tell me how many of each I have on the left side or the reactant side? How many sodiums? 0. 1? Everybody agree? Amen? Amen. Okay. Katie, could you tell me how many are on the right side of the equation?
1, wait.
How many chlorines?
Oh, sorry, 2.
Yep.
And then
All right, you're probably thinking, this is a really easy one. Yes, it is. Okay, but we're still going to go through the process and the steps. Next, third step, what do? Add coefficients to balance them. Okay? Looks like some of these guys aren't balanced. So, it doesn't matter where you start because you don't have hydrogen or oxygen, just choose one at a time. You decide which one you want to balance first.
Sodium.
Sodium balance, no touchy. Okay. Okay, let's do chlorine. Okay? Notice I have 2 on the product side, 1 on the reactant side, so I need more reactant chlorines, yes?
Yeah.
Okay? So I've got to put a coefficient somewhere up here that allows me to have 2 chlorines. What would I do?
put a 2
Where?
after the chlorine.
And
Right here. Coefficients come before. You don't put subscripts. Here's a common mistake that students think they can do. They think they can just go like this. Don't do that. It's not okay. Okay, once we put a coefficient, we're going to have to make some changes, right?
yeah.
Alright? We correctly changed and got 2 chlorines, yeah? The way to think about it is 2 times however many you have. Alright? That gives me 2, but doesn't that also change sodium? Oh. Sorry, my back hurts. Oh. How many sodiums now do I have? 2. But Mr. Kramer is unbalanced the sodium. It's okay, guys. We'll get it later. Alright. Now what? Let's balance the fluorines, okay? So it looks like I got 2 on the left, 1 on the right, so I'm going to have to touch and deal with the fluorine on the right. What do I do?
2 in front of sodium.
Like here?
No.
Oh, why can't I do that?
That's a subscript, not a coefficient.
Oh, because that changes exactly what that is and makes it not even possible. Okay, good kill, man. Yeah, you ever put a 2 in front of H2O?
You did it on the chart too.
Oh! Stop
Oh,
putting it up, Carly.
chill your britches.
Wait, change the ones on the chart.
No, change your face. Okay, so that gives me how many fluorines?
Can't tell.
2.
Too many different 2.
And how many different sodiums now?
2.
Voila!
No!
We got 2 of everything. Correct 2 or incorrect 2, still got 2. Okay? Never mind. Different 2s is what we're complaining about.
Oh, okay.
Yeah. Yeah, now we got it. Okay, yeah. Yeah. All right. Now notice when I balance the fluorine, it just so happened that I balanced the sodium, right? That happens sometimes. Ready for, I'm hoping, a harder one. That's not much harder, but we'll do it anyways.
Popo. It's Popo.
Hey, why don't you guys do this one on your own? Give this one a gander. Well, Don't just gander at it. Do it. But you gotta look at it to do it, so.
Gander at it.
Follow your steps. Make a T-chart. Put the atoms in the T-chart, how many of each you have on each side. And then begin putting in coefficients to get these guys to balance. Don't put too big of a space here.
Oh, yeah.
Otherwise, you might feel like you would want to put a coefficient in between there, which is not okay. Now, some of you might be able to do some of these without making a T-chart. Just if you don't make a cheat chart, I can't say anything today. If you don't make a T-chart, you don't show your work on a test, I can't give you any partial credit. I don't know what you did. Just don't get it wrong if you don't. Got an answer? I'd love to see if you got it right. Kind of squished.
Yeah.
That'll do. Yep. C. Yeah. Not so squished, but yeah. Anybody else? Got her done. Katie, have you started?
Yes, that's almost good.
Okay. What did we do in the very first problem when we had a number that didn't go into another number real well? Did you not write it down?
No, I did, but I don't, it's just 6.
Okay, so we had 3 and an 8, right? That's what we originally had. Okay, and 3 didn't go into 8, so we had to figure out which was the least common multiple, right?
10, so then I put 10 right?
No, you put whatever number there gives you 10 oxygens.
Oh, it's tough.
5.
We'll hit
You
on
put a
one.
5 here, you'd be saying 5 times 5 is 25, right? So what number would, well, 4 times 5 is 20. What number would you have to put here? What essentially would you multiply by 5 to get 10?
2. Oh.
Everybody figure out the least common multiple out? Yeah? No? Who does that help you? Least common multiple, a little subtle swerve of a hint? No, not helping at all? Alright, let's do her together then.
Yay!
Ladies and gentlemen. I'm hoping you were at least able to get that.
Amen.
Okay? You could have started by balancing phosphorus. The only problem with doing that is you're going to have to change it later, which is okay. You can change coefficients. For example, you could put A2 here and then change it later. That is okay. Okay? But to save us the headache of having to do that, let's do the oxygens first. You're probably wondering, how in the world do I do the oxygens? Because 2 doesn't go into 5 and 5 doesn't go into 2. So what do? Least common multiple, which means 2 and 5, what do each of them go into? 10. Okay? It's really just take 1 and multiply by the other. 2 times 5 is 10, 5 times 2 is 10. Okay. So, then you need to ask yourself, what would I have to put here to get 10 oxygens? 2, because 2 times 5 gives you 10. Now, common mistake. They go, yes, I got my 10. And then they move on. Why can't you move on? Because it also affects the phosphorus, which means I now have how many phosphoruses? Ah. Okay, then move back to the first side. And then you can figure out from here what you would need to do. How many phosphorus, or what coefficient we need to put here?
4.
4 times 1 gives me 4. And what coefficient do I have to put in here? Now we are what?
Rolling like butter.
Rolling like butter. Okay, rolling like a butter down a hill. Okay. Questions? Anybody? Okay? If it doesn't go well into it, remember and think least common multiple. Ooh!
Oh no! We only got 2 minutes left. I'm sorry.
Oh, let's do this real quick.
Oh, I have to switch the page. Fine, I'll do it on the back.
Alright, so I'm going to go through this relatively quickly. How about that?
Carbon dioxide.
Carbon, oxygen, hydrogen. See? Now, this is where it becomes a little tricky. Carbon, I only have one. How many oxygens do I have?
So second.
On the left side, though.
3.
I have 3.
Still writing down.
I have 2 here, plus 1 here. I'm going too fast, huh?
Yes.
Alright, get this in. Sorry.
Teacher.
Sorry.
So which one do you do last then?
Good question. Got it now? So we can begin talking about it? Okay. So, notice I have oxygen that appears twice on this side, so you got to count both. That's what this plus sign comes in. 2 plus is?
3.
Okay, hydrogens I have 2. Stay with me. I'm going to kind of go relatively fast. I got 6 carbons. I've got 12 hydrogens, right? And how many oxygens do I have?
8.
8. Ooh-wee. Okay. Which one should I balance first?
Carbon.
Carbon, because it's not hydrogen or oxygen. Let's put a 6 here. How about that? Now, slow down when you have multiple of one element. Because I have 6 times 2, which is plus is what?
13.
Oh boy. Okay, ready? Now, it looks like oxygens are real hard to deal with. So let's deal with the easier one. Why would I say oxygens are hard to deal with? First off, those numbers are nowhere near each other. Second off, oxygens appear twice on both sides, so that's to stay away from, right? Okay? Hydrogens only appear 1 on each side, so let's deal with it. What would I have to put to get 12 hydrogens? 6. That gives me 12. That's going to change again how many hydrogens I have. So I have 12, following? 12 oxygens plus 6 oxygens. How many is that? 18. Whoopka. No fun. Maybe I chose too hard of a one for the time that we have. No, it's not too hard of a one. Okay, that's not that hard. Let me show you. Am I going to want to touch this at all?
No.
No, because if I touched it, I would get the carbons and hydrogens to be unbalanced, correct? So that's locked in, which means the only oxygen I can touch is this. So, we have 6 untouchable oxygens. Okay? So, I have 6 untouchable oxygens. So, 18 minus 6 means I need 12 more, right? And can I change this to get 12?
6.
Put a 6 in front of it.
Now I've got 6 plus 12 is? There it is. It is balanced.
I don't get by.
That one was a harder one.
But it really does
Sorry guys, the manipulation.
Forgive you.
I want to make sure that I go through as many examples as I can. How dare I value education over your health?
That's what we have to do anyway, so it doesn't matter.
Still matters.